So this is actually the sensor board that we have developed. I will actually show you the device. So this is, it can act like a weather station. So a whole weather station or weather pollution station can be miniaturized in a very simple device like this. So what's description of the system? Actually, it's so there are some technical terms there like ZigBee protocol, real-time processing, flexibility, a system that can be extended. Also the devices. So what we did is that each device here, it has a built-in sensor. So we have chosen humidity and temperature. They are built in. And then you have here, you have a set of inputs actually here that you can deploy. You can use any sensor you want, CO2 sensor, solar radiation sensor, chemical sensors, whatever. You can just plug them into the device and they will transmit the data for you. So it's really very, very flexible. So it's modular. It has, so it's modular in the sense that it's composed of blocks of devices. If a device, for example, you don't need it, you just remove it. It will cost you less. We have here, for example, a GPS receiver. If you don't want the GPS to be in every node, you just remove it and it will cost you $100 or $50, $80 less. You have here a solar cell here, actually to recharge the batteries. Okay, so you can use these batteries. We have here a block of it's a wireless transceiver. So this is a wireless transceiver. If you want to upgrade it or change it or use another protocol, that's fine. You just unplug it and then use another one. This is the antenna for the wireless. So we have a strip antenna here, small one, which is 50 meters. But if you want to use another one, it will go up to 400 meters. Okay, so this has been tested. It's not theory. It's not theory. It has been tested in the field. So now, if you look at the board itself, the board has a backup battery for the GPS receiver, which means that the GPS receiver actually works at the normal mode. It doesn't have to be initiated every time because initializing it takes time and also consumes energy. So we have a backup battery for the GPS receiver. Also inside this board you have a memory of 128 meg. But if you need more memory, it's possible. There is no problem in having it. And it has also built-in sensors. It has so these are generic sensors which are very cheap, and it's good to have redundancy in many applications. It's good to have measurements of temperature and humidity here. These are the generic sensors, but we have actually in all of our boards. However, the board is not limited to that. You can, if you want, for example, an air dust, this is air quality sensor. If you want to use it, just plug it. Okay, plug it like this, and it will measure the air quality and transmit it wirelessly. So how it works? It will you can have up to 8 sensors in this board. However, if you have, for example, different ports in the given environment, you can have different sensors. You don't need to have exactly the same sensors in each port. Now how it works? The sensors will make measurements. They will transmit it they will store it in this memory. The memory, if you want it in real time, it can be transmitted right away. If you just want to collect the data and transmit the data, for example, at the end of the day, that's fine. So there is no restrictions on that. For the same thing for the GPS receiver, you can use a GPS receiver, and the GPS actually will measure, will calculate the position, and the position goes directly, with the data that you measure. It can be, for example, for pollution monitoring in a city, where, for example, this device can be installed in cars or in public transportation systems. For example, when the car moves, it will measure, it will approximate or calculate the position at the same time measure any pollution indicators, gases or chemicals or whatever, and then transmit them side by side in the same packet. So we have packets here which are transmitted with the position which is transmitted as well. So you don't need to worry about position or if there is an inaccuracy, or the technicians, for example, who have transmitted the device, have deployed the devices, for example, have made mistakes and so on. So it's really very, very, very has circulated for you, and if you have any questions, you can. I just removed this. I can include. It's a non-dust sensor, but of course it can be. Okay, I have another one just to. But it's more simplified. It's more simplified than the first one, so I don't have GPS here. I just have my wireless transceiver and my wireless transceiver and the import sensors. Okay, so I think I explained that. So what are the features? First of all, as I said, it can be connected through satellite. So you have the site where you're actually making your measurements, and then you transmit by satellite through cellular or Wi-Fi. We have the possibility of over-the-air programming, which means that from your office, you can activate sensors, deactivate sensors, increase the frequency of transmission, increase the data rate, for example, activate a camera, for example. We have a camera also that can be considered as a sensor as well. It can be, it's an extendable solution which is based on ZigBee. We have built-in sensors and GPS as well, so these have been described. It's modular, as I said, which means that you are not really restricted with the architecture which is there. You can have your own architecture, just change the modules or upgrade them. It can accept any kind of analog sensors or digital sensors, and also it's scalable. Scalable means that you, because we have this hop-by-hop communication, you can add a sensor node without really making any harm to the network. So it will just work. It will just connect it because it works on a hop-by-hop basis. And then we have some power-saving features here. There are technical details. Actually, I'm not probably going to enter to that. And then other specifications. It's lightweight. I think the weight, excluding the battery, is about 80 grams. 80 grams. With the battery, I think it goes up to 130 or 120 grams, depending on the battery that you'd like to have. We are working now on the packaging. So the packaging also is very light. It's waterproof. So it has a lot of features which are very interesting for environment monitoring. Now for the transmission range, it can go up to 350 meters. And also for the voltage range as well is a wide range for voltage. These are some results that we have made at Queen's campus. We are planning to deploy this in one of the forestry sites of the Ministry of Natural Resources, most likely this summer, to test it on a real forest field. However, we did some tests at Queen's campus, so we have here nodes in the campus. And here, for example, you have node number 2 that gives you the pressure, it gives you the temperature, the date, time. Also gives you the level of your battery, the voltage of your battery. It tells you if there is any problem with the network, if there is any node, for example, that has, for example, power which is decreasing, and you have to undertake the necessary measures for that. And also we have GPS information as well, the position information. These are same thing. So we have a system that has been deployed in the campus, and you have a set of 5 sensors. You have the battery history, you have the temperature history, you have humidity, pressure, and air quality measurements. This is an example of the temperature measurements. So we can have here we have measurements every 5 minutes, I think. Measurements every 5 minutes. So temperature went down here and then went up. So from 3 a.m. to 12 p.m. Okay, this is for power. So what's the expected outcome of this technology? First of all, it gives you better resolution in time and space. So if you have a given environment, instead of having just one sample in that environment, you can have as many samples as you want. Also, we can control the sampling in time. You can make more measurements. You can make less measurements. So it depends on your need. Also, we can collect diverse types of data. For example, it can be temperature, humidity, whatever measurements you need. And you are not really restricted with the technology, which means that this technology gives you a lot of flexibility. If there are new sensors that you would like to test, this is also possible. Images also, it's possible to have a camera. We have actually run a system for some tests for transportation applications to mitigate the collision between vehicles and wildlife in highways. So we are trying to test this with the Ministry of Transportation. So the users actually can collect data and then improve the quality of their measurements. They can react rapidly to events, which means that if there is something happening in the environment, then a real-time reaction can take place. And as I said, the number, type, and location of sensors can be modified as well. So for the potential applications, of course, we did this for environment monitoring, but there are a lot of other applications that can be considered: weather, ecology and pollution monitoring, precision agriculture, building and house control, medical healthcare, public health, food and drug traceability, industrial processes, quality control. So there are many applications actually that can be generated out of this device. Okay, so thank you very much. And the partners, of course, that I have to mention: the OCE Lunaris Corporation, Ontario Ministry of Natural Resources, and CMC, Canadian Micro